So good morning again, and let us start with the next point. Last time we started with something called as inheritance, and if you can recall, we compared inheritance with something called as an association. So if you can recall the difference between these two, association means the object gets created outside of your main object, and inheritance is the other object will be created inside the other object. So base class object gets created inside the derived class object. That's the main difference between association and something called as inheritance. Now we started inheritance last time. We created a couple of classes and we just looked at a kind of introduce or maybe higher level or introduction to the inheritance. Now today we have to move forward and we have to start looking at different types of inheritances. So as usual, I'll start using page 1 and there we'll say this is going to be a class, very simple class. I'm going to say this is the person class. Okay, this is the person class. Probably I'm going to start with getting all the default members like what we were getting last time. Name, address, and age, more than sufficient for us to start with. As usual, we are going to say self underscore name, or simply self name is equals to name. Self dot address, which is equals to an address. To be very precise, this is again not underscore but only address. And then self dot age is equals to self age. Like last time we have said, we are going to have a method like print person info, which is going to be used for printing the person info. So look at this in this way. Print name is equals to self dot name. Here using name is mandatory. I mean, you cannot just say name here. It has to be self dot name. That's the reason why, Rohit, you are getting an error there. Okay. So print, I think we need to print an address. So probably self dot address. And finally print the last one is age, where we can say self.age. Okay, so probably we are having a class here. So class is the person is having some data, and probably when we are having the data here, we want to reuse it in other classes. So probably I'm going to create a new class. Maybe I'll create a class like a player, for example. Player is nothing but any player, and I would say like player is a kind of derived class of person, or every player is a person. So I want to say that player is derived from person. This is the way we can do it. Now probably maybe for player, I want to add a few members. See, every player will have a name, something like this. Every player will have an address. Every player will have an age. And other than that, a player will play for a team. So that's a team member. Now, if you can recall, I mentioned this, when you are creating a derived class, it's mandatory for me to call the base classes initializer. So this is what we are going to do now. So probably right here, I'm going to call person dot underscore underscore init. We'll have to pass self along with the other members like address, age, that's it. And remaining part, that's a team, we can add it right inside the player class object. So maybe I'll say this is going to be a team, which is equals to team. This is something what we have discussed earlier. So probably right here, I'm going to say def print player info. And probably right here, we can print the player's info. So probably I can say something like, what is this? Maybe name, address, and age. I can simply copy and paste these members or these statements. And along with this, we can also print the team. So probably the team is equals to self.team. That's it. So this is the way we can create a player class and a person class. So let's create an object of them. So this is the person one, which is going to be created as a person class object. Maybe this is the person one. Maybe the person is from Pune, for example. The age is equals to say 10. Who cares? Let's call that person one dot print. You see that there is only one method available, print person info, and probably we will call it just to get all the details about a person. Now similarly, I can say player one, which is equals to person one. Oh, sorry, not player, person, my bad, player. And there we can say this is the player one. For example, the player is from Mumbai and player is having an age of 20, for example, and player is playing for Team India. Who cares? Something like this. So we are having all the details about the player. Now see here, when I say player, you see we are having two options, print person info and print player info. So if I say print person info on player's object, probably you can see it is going to print only name, address, and age, because person info or print person info method cannot access the team member of player. So if I say run, probably I'll be able to get both the details like name, address, age for person one, name, address, age of player one. But only problem here with the player class object is like we are not able to get the team. So that's the reason why we have another method, print player info. Okay, so instead of calling this print person info, I want to call that print player info, and probably that will solve my problem. So if I say run, probably now I can see, yes, name, address, age, and a team for a player, name, address, age for a person. So things like whatever we have expected last time, they are working like this. I mean, they are working as per our expectation. So things are looking good. So whenever you are talking about inheritance, this is how we can define it. We are going to say that player, maybe you can say is derived from person class. As simple as that. There is no complication here. It's single, I mean, there's only one class and there's another class. One class is derived from another class. That's how we can understand it. Okay, so I hope, let me open my notes and let's see where we are, and probably from there we can continue. This is not for you. Probably this is Python, here it is. So let's continue with the next point then. So probably we're thinking about going for the different types of inheritance. So we started with the inheritance. Now let us see what are the different options available in the inheritance part. What are the different types available in the inheritance part? Okay, so let's start with the simplest one. Now I'll try to be very very open with this, because this is something which is a very important part, not only in Python but also in all the languages which are supporting object-oriented programming. So understand this concept, understand different types, because whenever you see a problem, you have to first understand which type of inheritance you want to go for. So that's important part. Let us see the simplest one. This is called as a single inheritance. Now what do you mean by single inheritance? Single inheritance means there is one base class and one derived class. So probably whatever we have done so far, in our case, the one which we just started now, that's person and player. This is an example of a simple single inheritance class. Single inheritance in a sense, this is an inheritance where, okay, this is an inheritance where we are having one base class and one derived class. This is called as a single inheritance. Sometimes many people refer it as a simple inheritance as well. So this is something called as a single inheritance. Let me show you it diagrammatically. So probably right here, I'll create two classes, person and player. So I'm not going to go for all of them. I'll just cut down few things here, because we just want to understand this thing. So I'll just get only one. That's name, more than sufficient for us to understand. And this is my person class. See, this is my person class. And I'll go for the player class as well. So maybe this is the player class. So let's continue with this and say, we just need only name and team. That's it. So name, that's it. Don't need anything other than that. And the team. So probably we can write one more function like this or method like this, and then we can create another class. So we have two classes here, person class and player class. Now I want to create an object of player class. I'm not interested in the person class object, because that's a simpler part. We are talking about the main, that is a derived class object here. Okay, so probably I'll do one thing. I'll say that this is a derived class object. Maybe this is the base class object, and this is the derived class object, and we are interested in derived class object. Okay, so this is what we are interested in. So let me put it here, and probably this will show you like how the diagram, how the object gets constructed. So when you create an object of player class, this is how it is going to be represented. So probably I'll say that this is a kind of a class object, player class object. Again, you know that when I say player class object, that simply means there will be another reference here somewhere which will point to it. That's pretty normal now. Okay, you already know this part. Okay, so what I'm going to do here is I'm going to start with the person, and then I'll wrap it in player class. We know that in person we are having two things. So probably we are having something like a name, which is a kind of name, which is a kind of, what's the name? Player one. Okay, so the name is kind of a player one. So that's the player one, that's name. And we are having a method like print person info. That's a method. So these two things will be there inside your class. So probably I'll just go back here. I'll say that this is a person class, and we can understand like this is the person class object within the player class object. So this is how it is denoted. This is how it is kind of referred. Now on top of this is how the object will get created. On top of it, you are going to have the team as well. So probably I'll say team, and this team is India. Okay, then along with this print play person info, there is print player info as well. So this is what you're going to find inside the outer class. An outer class object, in a sense, that's a player class object. So this is how you can say the player class and maybe person class, they are related to each other. So again, the inner class, or maybe the inner object here, the one which you see, is the person class, and the outer class object, that's the that's in yellow right now, that is representing the player class object. So just for your understanding, again, this is the person class, whatever you see here, person class object, and this is the player class object. So in every single player class object, you always will find a person class. That's very important to understand. So this is called as a single inheritance. So probably what I'm going to do here is, like, I'll simply cut it down, and we'll create a separate diagram out of it, and then we'll put that right there inside your so-called notes. So not this one. I think in Sunbeam we'll have to go for notes, and we are in Python right now. Let's go back here. I'll say single inheritance. Okay, so that will make your life simple. So probably we have saved this here. Let me come back. Let me try looking at its preview somewhere here and see how does it look like. So probably right here, I'm going to say, yeah, that's a single inheritance .png. Okay, so there it is, and this is how we are going to look at an example. Okay, so instead of using this class here, I'm going to go for the class which we have started. Will be very simple for us to understand what we are doing. I don't want to go for all of these things because not required right now. For our example, we need only this part. So this is what we are kind of showing inside this particular diagram. So this is what you might see here, very, very simple. So this is something called as a single inheritance. Sometimes it's also referred as a simple inheritance as well. So probably that is going to, yeah, that is going to work. That's it. So this is a single inheritance. Please remember that. So this is single inheritance where we are having only one single base class, one single derived class. That is called as a single inheritance. And this is an example of it. And this is the diagram. I hope you can understand. There is nothing here. Whatever examples we have seen so far, all of them represent the single inheritance examples. So this is a single inheritance where we are having one base class, one derived class. That's it. Okay, so probably this is the simplest one. Now let us continue further and look at a couple of other options. Now this is a multi-level example. Now what is a multi-level? Now I don't want to go for adding all the members and other things because it will take unnecessary time. So if you can understand, there is a class, maybe base class and derived class and other class. So probably you can understand how those classes can be inherited from one to another. Pranit, what are you saying? Can private member in a base class be accessible in the derived class? Very good. Let's clear that point as well, and then we'll move further with the next slide. Okay. So probably what I was doing here is, like, I was making all of them as public. You remember, we already have talked about this. When we do not have any kind of underscores, this is completely a public member. So anyone can modify the data on top of that object. So player one dot maybe name is equals to, you see, it's like corrupted. So probably whatever you can say, it seems like we can modify it. And if I say run, you see, it's kind of a corrupted here. So basically, this is something I want to avoid. How do we avoid this? To avoid this, maybe we can say, instead of using name, we can go for underscore underscore, make them private. But when you make them private, let me show you the problem and see how you can fix this problem. So probably when we are going for this, this is a kind of not public anymore. All of these members are private. So when you talk about the public, we don't use any underscore. And when we talk about the private, we use double underscores. That's how we already have understood last time. Okay. Let me run this code now, and probably you will see that it's giving me a problem. It's giving me a problem because here you are trying to access them as kind of self.name, self.address, and self.age while printing the data. Of course, these members are not private, not public anymore. If you try to access them by using underscore underscore, because these are private members right now, and if I say run, still they are not able to access. I mean, we are not able to access all the private members of our person class into the player class. It's not possible. It's not giving me any ways that to access all the members here, which means, Pranit, to answer your question quickly, we cannot access the private member of base class into derived class. Why? The reason is very simple. Private means those members can be accessed only within the same class. They will not be able to access, you will not be able to access them outside the class or inside your derived class. This is not possible. So how do I fix the problem? Because if I keep them public, then probably anyone can modify that. If I keep them private, then I'm not able to use them outside my class or inside my derived class. So how do I fix the problem? To fix the problem, we'll make them something called as protected. Now, what do you mean by protected? Protected means those members which can be accessed inside the class and inside your inside your derived class. So probably you can see here, instead of using instead of using no underscore or double underscore, we are using single underscore. I hope you still can recall, in Python, this is the convention, not the compulsion. In a sense, whenever you are thinking about to make a kind of an attribute as a private, protected, or public, you have to just use the conventions here. The convention here is single underscore for protected, double underscore for private, and no underscore for public. So see what happens here. Now I'm not using a single underscore. I'm saying now not using a double underscore. I'm using the single underscore here. So the moment I use a single underscore, let me see if I'm able to fix the problem. So if I say run, probably the thing started working fine, you know. So I'm able to access all my members of person classes and my derived classes as well. So basically, whenever you are having a kind of inheritance, it's always is always recommended to make your members of base class as protected members. Okay, so let me repeat myself. I think it's better I can just mention it somewhere. So when I say access specifiers, in other languages, those are literally keywords, and here we are having them as conventions. Access specifiers. Okay, now the first one is the public. Maybe I'll say no underscore, I'll simply say public, and then we'll say it's a no underscore. So basically, when you talk about public, that means no underscore. Means, again, when you say something like public, can be accessed outside of the class, outside the class. You can access it anywhere precisely. So you can access it inside the class or you can access it outside the class. There is no problem. When you are talking about private means we are using double underscore. So I'll say double underscore. So double underscore simply means you will be able to access them only within the same class. Can be accessed only within the same class. You cannot access them outside the class. That's what is more important here. And finally, just now we have looked at one more that is called as a protected. Now protected simply means you are trying to access them within the same class and you can access them in the derived class. This is something like a single underscore. Okay, this is the convention we are following. That simply means you can access it, can be accessed. So I'll say can be accessed within same class as well as derived class, you know. So that is the way we can do it. So probably when you say something like access specifier, always remember we are having three: public, private, and protected. In public, you can access this anywhere. Maybe you can say outside class or anywhere. You can access them outside the class or you can access them inside the derived class. Private means you can access them only within the same class. You cannot access them anywhere outside this same class. Protected means you can access it within the same class as well as in a derived class. So Praneeth, I think that answers your question. And not only that, probably others you also must have gotten to know, like there are three conventions to be followed. I'm again repeating myself. These are conventions. And when I say conventions, generally generally Python developers follow the conventions. And conventionally, no underscore means public, double underscore means private, and single underscore means it's a protected. That's a new thing we have seen today. So whenever you make something protected, you can access them within the same class, like what I'm doing here, access them maybe within the derived class, something like this. Now, I don't want to confuse you, but the things are like those can be accessed outside of the class as well. So probably if I say something like name, though it is not visible here, I mean, not visible in the sense when you say dot, you will not be able to see that here, but still, maybe I can just go back here and say person one changed. And if I try to run my code, you see that the changes persist. So whenever you are using protected, they can be accessed outside the class, but we should not. So don't consider this as a kind of a flaw in Python. But as I mentioned earlier, this is a kind of, again, a convention and not a compulsion. So basically this is not a compulsion, means we have to follow the convention that we should not access this outside of the class. So please try to understand, as I mentioned earlier, do not compare this with other languages. In other languages, probably you can just use them as a keywords, and then you will get what exactly behavior you are looking for. But here these are conventions, and we have to follow the conventions when we are writing Python application. Okay. Yes, Preeti, you got your point. Ketan, can we say all methods of base classes will be called implicitly in the derived class? Of course, yes. Did you see something? When I created that method print person info, I did not use a single underscore or double underscore. Means by default, it is a public. And because it is a public, I can easily access them inside my derived class as well. Okay. So Ketan, you got your answer. Shripati, how to access or call the class file from one page to another page? Shripati, hold your question. Tomorrow we are going to talk about something called as modules and packages. There you will understand how we can use this class outside of this file and how we can reuse it in other files. Okay, so tomorrow we'll introduce something like a module, and multiple modules coming together will create something called as a package. So you'll get the answer to your question by tomorrow. Adesh, is there any mode of inheritance in Python? No, there is no any mode. It's by default what I'm just telling you right now. This is convention, not like C++, public, private, protected inheritance there. Okay, there is nothing. Okay, so probably whenever you are talking about how to call the method of the base class and derived class, that's what we are coming back to that point. So just hold your question, Kaushik, you will get that answer right now. Okay. So probably when you talk about this particular behavior, it seems like everything is working. Priyanka, what are you saying? When to use init method, we use like definite blah, blah, blah. That's okay. So in this case, when we create an object of a class, there is only one, there only we need to give the parameters like a person one blah, blah, blah. If I take input from user and that function written in the class itself, how do we do that? Just hold your question, Priyanka. You will get that answer. Let us complete all the inheritance types, and then we'll create a we'll literally create a function application, and there I'll show you how to write a real life application where we can get the input, process them, and display the output. Okay, probably not only today, tomorrow also we are going to have this example. Maybe I don't know whether it's possible for me to show you all of these things today, but probably tomorrow also you will see an answer to your question. Okay. Anyways, so coming back to the point right now, whenever you're talking about an example like this, you are having one base class. Let me again mention, this is the base class and this is the derived class. This is an example of single inheritance. Single inheritance simply means we are having one base class and one derived class. And this is how the derived class object will look like. Remember, the outer part, the yellow part is a derived class object, and the inner part is nothing but a base class object. So remember it from that point. Now, please remember again, whenever we are using inheritance, it's always recommended to keep your members protected, so you can access them inside your derived class. Derived class member, you decide whether you want to go for protected or private. It doesn't matter, because there is no other derived class of player, so it doesn't make any sense to go for private or public or protected. So it's okay, you can do it anything there. So probably important thing is with the person, not with the player. So player, you can keep it private as well. That's not a big deal. So this is an example where we are having a single inheritance in picture. Now let us go back here, create one more example. Say this is page 2. And in this case, I want to go for one more layer, one more level. So think about the scenario. I'm going to create a class person one more time. In this case, I'll say only one member. That's the name. Okay, I don't need anything other than that. As usual, I'm going to say self.name is equals to name. Please see to it, I'm using single underscore there. Okay, def print person info. Why we need that? We'll just skip it right now. We'll just try to look at the class object. So we'll talk about the print methods and utility functions later. We are going to have one more class. Let's say a class is called as an employee. I know every employee is a person, so probably I can say that this is a person. I mean, employees is a person. Employee has a name. Employee has a company, for example. So probably I can call person dot underscore underscore init. We'll say self and we'll pass the name. Along with this, we will say self dot underscore company, just equals to the company. Now, if I want to go further in this kind of a chain or in this particular labels, then I can have one more class. So probably I'll say there is another class, something like maybe a manager. Every manager is an employee of a company and every employee is a person. Probably you see where I'm going now. So I have a person class, then I have employee class, and then I have a kind of manager class. So manager is derived from employee and employee is derived from person. So probably I'm going to go back here and say this is a init method for manager. See, manager is going to have the name, manager is going to have the company, and along with the company, manager is going to be having another field, another maybe you can say another attribute called as department. So probably here I'm going to pass the employee underscore underscore init self name and company, because the immediate base class of manager is employee like this, and so my employees init method is accepting name and company. That's what we are passing, name and company here. And then we can say self underscore department, which is equals to department. So if you look at this example here, we are having 1, 2 and 3 labels, and that's the reason why this is generally called as a multi-level inheritance. Multi-level simply means we are having level 1, level 2 and level 3. Okay, so probably when you talk about this example, there is only one level. That's the reason why it is called as a single inheritance. It's also called as a simple inheritance as well. When you add one more layer to it or one more level to it, this becomes a multi-level example. So think about this in this perspective. I'll do one thing. I'll just go back here. I want to add one more thing there. It will be easy for you to understand, hopefully. So probably, okay. So probably I'll do one thing here itself. We are having two classes here. That's the person class, which is the base class here. Please try to see what I'm showing here, because this is generally the way to represent whether it's a single inheritance, whether it's a multiple inheritance, multi-level inheritance, or what else it is. So this is a kind of a player class. And we say that the player class is derived from person class. So this is the way we are generally saying in the real world that the player class is derived from person class. So person class is the base class, and that's where we generally point our triangle like this one. So what you see here is a kind of way to say this is a single inheritance where player is a derived class and person is the base class. Okay. So probably this is the way to represent what exactly the inheritance we are looking at. So probably we are looking at this inheritance called as a single inheritance. And in single inheritance, you see the single inheritance, you see, this is where we are saying, yeah, there is a base class called as a person and there is a derived class called as player. So please try to understand this. This is the way we are generally saying that inheritance is implemented by using two classes. One of them is the base class and another one is the derived class. Okay. Now, when you go for multi-level, what happens here? So probably I'll just go back here and I'll create those three classes very quickly. All of them are right here now. This is an example where we can understand like how the multi-level inheritance object gets created. So this is a person, employee, and manager. So let me just arrange them in a better way so that we can create kind of, yeah, the hierarchy here. Okay, so what is happening here? I'm going to create an object of, let's say, employee and manager. I mean, I can create an object of this as well. Let's say P1 is equals to person, where we can say person 1. I can say E1 is equals to employee, which is having an employee name. That's an employee 1, and company, let's say company 1. And finally, M1, which is equals to manager. Manager is going to have a name, manager 1, probably. Manager is going to have a company, So I'm sorry, company one, for example, and manager is going to have a department. Department is, for example, computer, for example. So probably if you look at these examples, then you would understand easily that these three objects are having their the implementation in this way. Let me show you here. So the simplest one is going to have the name equals to person one. So that's the person's attribute name, and we are saying that this is the person which is going to have only one single attribute here, and this is how the person p1 object gets constructed. Now I'm not showing you the another reference and other thing, this, so I don't have to talk about this again and again. So think about this from this perspective. This is a person class object. Now when you say person class object like this, I'm sorry, this is not person, no, person, so it's my bad, it's person one. So this is person one. Okay, so that's how we are talking about a person class object. Now coming back to the next example, let's say employee class object. Let me bring it here, and on top of it, you can understand now, on top of it you are going to have one more extra object. You can say this is a kind of a wrapper over the person class object, something like this, which is going to be a kind of company. So probably I'll say here company, which is equals to company. So that's how we are kind of saying the company attribute is given by employee. So that's not person anymore, that's an employee one. Let me just delete it and say this is going to be an employee one. Okay, so this is an object we have created here, which is an employee, and employee object looks like this. So this is how we can say the employee object gets created in the memory, which is having a person class within it. So what is it? This is a kind of employee. So this is an employee class object. Do you see that here? And if you see it here, probably the next object is going to be exactly like this. So just let me get it here, and probably now you can understand it will be just one more extra layer on top of it. It will be a kind of maybe coming back here, it will be a kind of manager layer. So this is a kind of a manager class. I hope you can understand what am I showing you here. This is a kind of manager's department. And when you say this is the department, for me the department is computer. So I just added that inside my object, and this information will be stored like this. So department is an object, it's a property of manager class. So that's how we can see to this particular example. Now let me just try to show you in a color format like this one. This is person. Maybe I can say this is a kind of employee. This is a kind of an employee, and on top of it we are having a manager class. So probably you may understand this in this context. We are having an employee class object which internally will have a person class object, because the person is a kind of base class for employee. Whereas when you talk about the employee class, you see the employee class is when you talk about the manager class is going to have an employee class which internally will have a person class. So manager is derived from employee and employee is derived from person. So this is how the hierarchy will look like. And if you want to look at a kind of way to represent this inheritance, this is how you can say that there is a player, there is a person, there is an employee, and there is a manager. So this is how we can say these classes are kind of derived from each other. So probably I can say this is the person class as usual, this is an employee class as usual, and this is a kind of a manager class like what we have seen last time. So whenever you want to see the hierarchy here, like who is the base class, who is the derived class, and stuff like that, then you can say this is how the inheritance is kind of implemented. Again, like last time, I'm going to say there is a relationship between person and employee, and there's a relationship between an employee and manager. So probably when you say there is a relationship between employee and person, you know that the person is a kind of base class for employee. Similarly, employee is a kind of base class for manager. So probably I can say that this is the base class for manager. See, this is the way we are going to represent the information here. So the information, it's okay, it's company one, sorry, my bad, Adesh, absolutely you are right. Should I say that this is company one and company one here? That's a value we have added inside that attribute here. Absolutely right, correct. So this is the way we can represent the information, and we can say, yes, this is a kind of a hierarchy we are talking about, you know. So this represents a multi-level inheritance. We are having two levels, level 1 and level 2. So this is the level 1 where we are having the person and employee, and this is the level 2 where we are having employee and manager. Guys, do you understand that? In the name of manager, it will be manager. Sorry, my bad. Absolutely right. I just copy pasted that, right? So that's right. You're absolutely right, brother. Let me just change it here. My bad. I got everything screwed up. I think it's my bad. I used a bomb here. This is called as a bomb. Unfortunately, you know, thank God these are there. Before I make any mistake, let me save this. Can't take a risk anymore, you know. So it's better we can save that somewhere in our so-called notes. So it will be easy for us to refer later. Thank God I could revive it. Otherwise, I would have again, in a, it will be very difficult for me to represent it again. So it's better we can say it's September 21 2. I'll save it first, and we'll save this one as well. It's September 21 underscore 1, you know. So this is what we are talking about. So we are having three levels, we are having actually three levels here. The level 1 is person 1, level 2 is employee, and the level 3 is manager. And as you said correctly, let me just remove that employee 1 here. This is a manager class, not so this is the manager value and not an employee value. So probably this time I'll make no mistake. Let me use the same color and say this is exactly what you said, right? That's manager 1. Absolutely right. Okay, so this is manager 1, and probably that is the value we are adding right here. Okay, so I hope you got it right now. Correct. Okay, so what you see here is the way we are representing a multi-level inheritance. Now, before I forget, let me just bring it back and say this is a kind of multi-level inheritance. Let me save this as well. So it will be easy for us to, you know, just put that in our so-called notes, and I'll share the new version of this notes today. So it will be easy for you to also see every single thing in one single notes. So let me come back here. I'll say that this is a kind of multi-level inheritance. Okay, so again, let me come back here in our so-called example here and say this is a kind of exclamation mark, multi-level inheritance dot.png. So probably you'll be able to see that example right here. So it'll be easy for you to recognize or realize like what exactly is going on. Okay, and the example I'm going to put here is not this. This was my older example. We already have a better example now. So let me come back here and say this is an example that we are interested in. So this is how multi-level inheritance can be implemented in Python. Okay, so I hope we are in a good shape now. We know now what exactly the single inheritance is, what exactly the multi-level inheritance is, and what's the difference between these two. You see, there is only one class, one single base class and one single derived class. Here we are having one single base class, and then there is a derived class, and the derived class itself is a base class for another derived class. Okay. Now, a few terminologies. When you're looking at this example here, probably I can okay, I can add this in another one, and probably I can show you that right there. Okay, so let us see it in from this way. So probably I have the same hierarchy I talked about, you know. So please understand this. When I say person is the base class. We talked about that. So this is a base class. I'm sorry, this is a base class, and because it is a base class, you can see that on top. So this is the base class here, so it's on top. This is a derived class. Now please understand terminology we use here. So derived class of person, but it's a base class of manager. Okay, and not only this, there is one more terminology coming. Just wait for a second. This is the derived class of employee, and there's no other class beyond this limit, so we can simply say it's a derived class of employee. Now, important thing here is when you talk about this hierarchy, I can say that The employee is the direct derived class of person. So probably I can say direct and indirect now. So probably I can say it's a direct derived class, sorry, derived class of person. So this is the direct derived class of person. Which one? Employee. While this is indirect derived class of person. Now, why am I saying that it is indirect? It is indirect because manager is derived from employee and employee is derived from person. So manager becomes indirect derived class of person. And on the similar line, I may say it's the direct base class. So maybe I can say direct base class of employee. At the same time, it's indirect base class of manager. I'm talking about something like a person class, so the person class is a direct base class of employee and it's an indirect base class of manager. Why am I saying it? I'm saying it this because I know manager is having an employee and employee is having a person. So person becomes indirect base class of manager and direct base class of employee. Again, when you talk about the manager, manager is indirect derived class of person and employee is a direct derived class of person. So probably whenever you're talking about the object of manager, if it is having an employee within it, the employee becomes a direct base class or manager becomes a direct derived class of it. I hope you can understand what am I talking about. More or less, you will see this terminology used everywhere in all the programming languages you are going to come across. So basically, we talk about direct and indirect relationship based on who is going to contain an object of what. So probably if employee is going to contain an object of person, I mean, if employee is going to contain an object of a person, then employee becomes a direct derived class, person becomes a direct base class. If the manager is going to have an employee, manager becomes a direct derived class, employee becomes a direct base class, so on and so forth. And you can increase that level as many times as you want, as depth as you want. So depending again on your requirement, you have to think about it and you have to go for it. This is called as multi-level inheritance. So in multi-level, you are having multiple levels. So this is level 1, this is level 2, and this is level 3. So where we are saying person 1, employee, person, employee, and manager. So that how it goes. Okay, so we know now single inheritance, we know now multi-level inheritance. I'm going to skip this multiple inheritance for now, just for a minute. We'll first finish the hierarchical and then we'll come back to the multiple. Okay, so what is a hierarchical? Hierarchical simply means we are having a relationship where one base class can have multiple derived classes. So let me first save it somewhere. Okay, let me go back to, should I go for this one? Okay, leave it. So probably I'll go back to my Sunbeam 2020, February 20, and it's better we can go for our Python somewhere here. And I'll save it as SEPT, that's September 21 _3. So that's the next one. Okay, so we talked about single inheritance, multi-level inheritance. Now I'm talking about something called as a hierarchical one. Now, what do you mean by hierarchical? Hierarchical means one base class can have multiple subclasses or multiple derived classes. For example, we are using here like person, employee, student, and player. Okay, let me show you that example because it's very simple to show you here. Maybe I can go for this example here first. We'll implement the classes and then we'll come back and we'll see how the diagram will look like. This is page 3. I'm going to go with very simple class, by the way. This is person class again. Person class is having again a def underscore init underscore. This is going to be a name only. Again, as usual, dot underscore name is equals to name underscore name means it's a protected member. Again, another class called as person, for example. I'm sorry, player, for example. So player class is derived from person. Again, like last time, I'm going to say init. Player is going to have a player's name and player is going to have a team. So again, we'll say person underscore init. That's the self. And then we can go for name. And we can say self underscore team, which is equals to team. So that's it. Another one, maybe I'm going to say a class, let's say an employee, for example. So employee is a again derived class of person. So that's how we can write it. Again, let me just not waste my and your time. Maybe I can just copy and paste it. And employee is going to have a company. That's it. So this is a kind of underscore company, which is equals to company. Similarly, I can go for one more class. Let's say a student class, for example, class student, which is also derived from person class. So this is a student class where we can have the school, for example, here, and then we can say self underscore school is equals to school. That's it. So when you look at this example, you see a person is a base class, player is a derived class of person, employee is a derived class of person, and student is a derived class of person as well. So this example is going to be considered as a hierarchical one. Why it's called as hierarchical? I'll show an example here diagrammatically. Probably you can easily understand that. It's pretty simple to understand. So let's see it in this perspective, So maybe I can just put them right here in this perspective like this. Okay, now I don't want to create an object myself, but you can imagine that whenever there will be an object created of person, player, employee, and student, how will it look like? So probably just for an example, say there is a person class, which is having a name attribute having, let's say, person one. So that's a very simple example. This is a person one, and probably you can say this is the person class object. Okay, so this is the person class object. Let me say this is person. Now when you look at the player, employee, and student, because all of them are derived from person, all of them will contain person object within them. Just give me a sec. Let me write in this way first. Let's add a color because it looks really bad after adding it. So it's better we can do it first. And then we can say this is the name person one. As simple as this. So probably I can say this is a person class object. And once we know that this is the person class object, I can simply use it, or rather reuse it in another classes. So just get it here. And I'll say that this is person one. So this is person, not person one. That's a person class object. And then we can come back here and say, hey, I need one more class object, that is a player, for example. So the player will look like this. Player will contain an object of a person within it. So that's how the player class object will look like. Now player will have another member like a in this case it's kind of a let's say a team, for example. So this is a team, for example. I didn't create an object here, but you can understand a team will be having, let's say, India, for example, again, like last time. So you can use double quote or single quote, that doesn't matter. So this is how the team will be added on top of this person class object. And this is nothing but the player class object. Okay, so that is how it goes. Now exactly similar, maybe I'll just go back and copy this one more time here. This is another class. Maybe you can consider this as an employee, and maybe you can consider this as a student class. So all of them will look almost similar. So this is the way you can represent that information here. So this is the person class, that is the player class. This is a, maybe I'll say the player class, student class, and employee class. So probably I'll say this is an employee. Should have gone for only two options, but it's okay. Anyways, we already have considered this here. So let's say this is an employee, and this is a student class. I think it's better to drop it because it's very simple for you to understand from this example. So student will also be exactly similar. Okay, let's not add more things into it because I need to add the hierarchy as well, So probably this is another class, totally different class. And when you say employee, employee is not having a team here. Employee rather is having a kind of a company here. So probably I'll say this is company, which is equals to company. And this is how we can understand that employee object is created, or company one, I'll say comp one, so that I can fit that in this particular boundary. So this is a kind of an employee object. Now, if you want to see it from the other point of view, there is a kind of person class, as I said earlier, and this person class is having two derived classes. Look at the way I'm representing here. So this is a person class, which is the base class, And this base class is derived in two different derived classes. One of them is the player class and another one is employee class. So probably you can say it like this. This is the player class as usual, and this is an employee class somewhere here. You see, the player class and the player class and employee class, both of them are derived from the person class like this. So probably now you can understand this is a kind of a hierarchical process or hierarchical inheritance. In hierarchical inheritance, you are creating a kind of hierarchy. So this is the player class derived from person, employee derived from person. And again, when I say derived from, there will be a kind of rectangle shown towards the base class here. So this is the way to represent this information. I hope you can understand that, you know. So employee and player, both of them are having a kind of something like a common base class. So there is one base class and we are having multiple derived classes. This is an example of hierarchical inheritance. Guys, are you getting it? Rajendra? Yes, exactly. That's the reason why I started with hierarchy first. So once you understand hierarchy, I'm just going to make it opposite of it to make it multiple inheritance. Absolutely right. Okay, so this is an example of hierarchical inheritance. So I'll say SAPD 21_4. It'll be easy for you to understand that. And let me bring it back here and say this is an example we are talking about for hierarchical inheritance, you know. So I'll save it here and say this is hierarchical inheritance. Okay, so this is hierarchical inheritance. I think I need to change the path. I'll have to put that in notes and Python somewhere here. So probably this is how we can do it, you know. And because it's already been referred here, I'm going to come back and say this is where we want to put it, and this is .png. Okay, so that's where we are going to bring the hierarchical inheritance into picture. Okay, so if I just want to bring those classes here, I'm just going to copy that and put it here. So we are having person, player, and employee, you know. So that's what we are kind of representing here. So that's how the hierarchical inheritance is implemented. So please remember, this was a single inheritance having one base class, one derived class. This is a kind of multi-level where we are having one base class, having one derived class, and the derived class itself is acting a base class for another derived class. So this is a multi-level inheritance. In hierarchical inheritance, we are having one base class and multiple derived classes. So that is called as a simple hierarchical inheritance. Now let's look at the little bit complicated called as multiple inheritance. So what is a multiple inheritance? Now let's look at an example from this point. So let me close this one. Let me come back here and say this is going to be page 4 right here. And I want to show you a simple example. See if you can understand this. Now imagine the scenario that maybe you are right here in Sunbeam, for example. So I'm here for helping you to understand all the concepts. So probably I'm saying like I'm representing a faculty here. So there is a class called as a faculty, which is having information like my name, my address, and so on and so forth. You know, maybe this is going to be again a name, and this is where we are going to show that information. You know, so probably this is the name and which subject I'm kind of teaching here. So this is a subject. So subject, and probably this is the subject. Okay, so probably we are having a class called as a faculty, and the faculty is the person who is literally sitting with you in one-to-one interaction, or maybe one-to-many interaction where we are having this session going on. Okay, now you are not there. I mean, we are not having a lab for it, but we are having other courses where we are handling the theoretical session or discussion session, and after that we are conducting the lab for them. When you go for maybe after this lockdown is over, and if you come for our Hinjewadi office, there you will find we are having a big office there where we are having many different labs. And after the session, generally people go to lab and they do the practice, literally sitting on their machines. So there we are having other people who are helping the people or helping the students to resolve the issues and to understand them again in a different context. So those people are the people who are assisting those students. So if they find any problem, they can fix the problem right there. So probably we are having a class called as faculty, the person who comes in a classroom and who teaches. So that's a faculty. At the same time, there are people, you can call them as lab assistant. So these are assistant to you people, so that if you face any problem, you can ask them and you can get your queries resolved. Right, absolutely, Utpal, Ganesh sir. So he's the person who is going to help you to fix your problems. Exactly. So probably I'm going to say that this is the person having a name, and this is the person having maybe a subject, or maybe a lab, for example. Instead of saying subject, I'll say lab. So again, self dot underscore name is equals to name, self dot underscore lab is equals to lab. Which lab he is assisting you? So probably this is a kind of example of lab assistant and a faculty, for example. But sometimes, I mean, it's not the hard and fast rule that if I'm teaching here in a classroom that I should not go for lab. Sometimes I also go there in the lab and I generally try to help them. So depending again on time. Generally, I don't go in the online sessions, but when we are in offline, when we generally go back to the Hinjodi, I generally go to the lab and then see what exactly going on, if they're facing any problems and stuff like that. So sometimes I play a role of being a faculty at the same time as a lab assistant. Now, if you think about a faculty who is just teaching, fine, that person can be represented as a faculty. If you consider a person who is just helping you in your lab, you can consider that person as a lab assistant. But if you think about a person who is playing both the roles, that person can be represented by using another class. Maybe I can say he's the faculty lab assistant, just for an example I'm saying. So sometimes he's playing a role of faculty. At the same time, sometimes he is playing the role of a lab assistant as well. When you talk about something like this faculty lab assistant, don't you see that he's going to have all the characteristics of a faculty, at the same time all the characteristics of lab assistant, which means this class will have two base classes. One is the faculty like this, and the other one is lab assistant like this. So this is the class faculty lab assistant, who is going to play a role of faculty as well as lab assistant. Now, there is nothing here other than the lab assistant and faculty data. Like the person is going to have a name, the person is teaching a subject, and person is handling a lab. So probably this is how we can solve the problem. We can say something like faculty dot underscore underscore init. Maybe I'll say self and name and subject. At the same time, because there is another class, we'll have to call the initializer of that class as well. So probably name and the lab. Now, probably you can understand this class here is representing the faculty as well as lab assistant. So this is a combination of faculty plus lab assistant, generally called as multiple inheritance. Multiple inheritance is the way you can say one class is having multiple base classes. You see, the faculty lab assistant is the class which is having the faculty and lab assistant as multiple base classes. And that's the reason why this is sometimes literally complicated, and there are many languages which do not support this type of inheritance. Hardly a few languages, I mean, you can count them on your fingers. Hardly a few languages support multiple inheritance. C++ is one of them, and Python is another one of them. So these languages do support multiple inheritance. So this is how it is kind of implementing here. Do you understand what I'm talking about? Think about it from real life perspective. There is a faculty, there is a assistant, and this person is playing both the roles. Okay. Probably think about this. One more example, see if you can understand. Maybe when you go to company, or many of you are professional right now, so probably you can understand this example better than this. So probably those who are coming from the other courses, maybe you can understand this faculty and lab assistant. Maybe those who are really working in the companies, you can understand this example. Say there is a class called as a developer. So when you say this is the developer, maybe developer is going to have some data. So probably I'll say the developer is going to have, my bad. A developer is going to have some data like developer's name. Developer's name and a developer's technology, for example. Technology, which technology that developer is working on, for example. Again, self dot underscore name equals to name, and self dot underscore technology, which is equals to a technology. I mean, this is not right in the sense, this is not right implementation, but for understanding, it's okay. So maybe we are having a developer class, and on top of it, I'm going to have one more class called as, let's say, a tester. You know, so tester is a person who is literally testing the applications. So probably I'll say this is the name and which application the person is testing. So this is a tester, and again we can say name is equals to name, self dot underscore application is equals to application. You know, so which application the tester is testing at the moment can be used or can be added inside that tester class implementation. We are having a developer class, we are having a tester class. But you know what? When you are having a small scale company where a person is performing both the roles, maybe he's a developer at the same time he's a tester as well. This is a good example for big short companies where we are having only development team and only a tester team. Testing team will do only testing part, development team will do only development part. But there are small scale companies where the developer is performing the tester's job as well. So probably I'm going to say this is my developer, for example, my company developer or small scale company developer, where this person is performing a role of development or a developer, and is also testing the application as well. So he's performing the job of tester as well. So probably I can say dev underscore underscore init. The person is going to have a name. The person is going to develop an application by using a technology. At the same time, because this person is also testing an application, so which application is he testing? I can use that application there. So probably I can say self underscore, and I'm sorry, self developer, not self, sorry, my bad. It's a developer underscore underscore init. We are having a self, name, and technology. At the same time, we are going to have a tester dot underscore underscore init, and then there is a self, then there is a name, and then there is an application. So that's how another example you can see where we are having one base, I'm sorry, two base classes and one derived class. When you're doing something like this, you can definitely say that this is an example of multiple inheritance. When I say multiple in the form of base classes, multiple base classes, one derived class. This is an example of multiple inheritance. So see, seems like faculty lab assistant is kind of combined together here, and a developer and tester combined here. So probably you can understand that it is an exactly opposite of it. In this hierarchical, we are having one base class and two derived classes. Here we are having two base classes and one derived class. That is called as a multiple inheritance. I guess you are getting the point. Shrikant, what about the diamond problem in multiple inheritance? You will not face any diamond problem here, because we are not playing with the pointers. It will automatically get memory will get automatically managed, so you don't have to worry about it. So Shrikant, there is no diamond problem in Python. Python loves diamond. So Python does not have any problem with the diamond. Maybe C++ doesn't love diamond. That's the reason you will see that diamond is a problem in case of C++. But here there is no diamond problem. Okay. So probably if I want to show this diagrammatically, let me just go back here and probably let's bring this example. You can get this or this. Both of them are exactly similar examples. It's just understanding is more important for me. So probably I can get those three classes here, and probably we can say that this is a combination of two classes there. So probably you can say this is how the classes are implemented. This is the first class, second class, and third class. Okay. Now how the classes will get implemented, pay attention. This is a little bit different than what I showed you earlier. Not little bit, completely different. So probably this is the name, which is equals to, we need some data. So we'll understand how it is coming from or where it is going to. So this is F1, which is equals to faculty. Faculty is going to have a name, let's say F1, and faculty is going to have a subject, let's say Python, for example. Okay. Let's say this is the lab assistant L1, LB1, or LA1, lab assistant 1. I'll say the lab assistant, and probably the person name is LA1, lab assistant 1, and does lab. So he is going for a Python's lab, you know, for example, like this. And there is a person like faculty lab assistant 1, FLA, faculty lab assistant 1, which is again faculty lab assistant, and this is FLA1. And he's teaching the subject of Python. At the same time, he's also handling the Python's lab as well. So this is an example of the multiple inheritance. Just let me go back here and let me put it right there so you can understand now like how the objects hierarchy gets constructed in the memory. Please pay attention. This is literally different than what I showed you earlier. And that's a special case. That's the reason I kept it after the hierarchical inheritance. So let us look at that F1 first. We are having two members. Name is equals to probably F1 and the what is that? Subject. Subject is having Python. So name is equals to F1. That's a faculty one. And the subject is a kind of Python. So this is how we started creating our faculty class object. So this is F1. Okay, now let us look at the lab assistant. So probably I'll bring that lab assistant here and I'll say that the lab assistant is going to have a name. So maybe I showed that LA1 and the lab assistant is going to have a kind of a lab. So this is the lab and I'll say Python lab, So that's another class which is of type lab assistant. So this is a lab assistant class and that is a kind of the faculty class. So let me just show that this is a kind of a faculty and this is a kind of lab assistant. So please see to it that you are getting it, and if you're having any problem, ask me immediately. Lab assistant. Okay, so now you know that there is a class faculty, there is a class lab assistant, and probably you can easily identify them with their default or with their different members. So that's a name and subject, and that's a name and lab, faculty and a lab assistant. Now when we go for faculty lab assistant, that's a completely different class. You see what happens here. Whatever class you have created here, that's a faculty, we'll just bring it here. And another one, that's lab assistant, I'm going to bring it here either. So probably you can say that this is the class which is made up of combination of these two classes. So the object of lab assistant, faculty lab assistant, will look like this. You see, it is having both objects in them. So probably other than that, we don't have anything here. But if you want, you can add anything on top of it as well. So probably this is how the faculty lab assistant class object will look like in the memory. Please see to it that when we are talking about the derived class, the multiple inheritance, the derived class object will have the object of both base classes. When I say both the base classes, you see there is a faculty and there is a lab assistant. Both of them are there. So that is nothing but my faculty lab assistant class. You see, that class is having an object of faculty and having an object of lab assistant in them. And that's the reason I hope you can understand. Here we are calling the faculty's initializer as well as lab initializer, meaning we are having both the objects within the outer object. So this is an outer object, which is kind of having, let's say this one. So which is having both inner classes. So faculty as well as lab assistant. Okay, are you getting this? Probably looking at this diagram, you will understand that we are having two base classes or base class objects within a kind of derived class object. So this is an example of multiple inheritance. Okay. Ketan, is there any property like static or non-static methods? Ketan, we'll see that. Right now we are in the context of inheritance. Let's finish this subject and then we'll go for the next point. Okay. So yes, there is something, but we'll talk about it right after this. Pranit, if the base classes have the same method, then which one will be called at the runtime? It doesn't matter which one will be called, because you have to call this explicitly. Wait for a minute. I'll show you an example of this. I haven't talked about how to call base class method from derived class. I'll have to still show you that. Just wait for a minute. We'll talk about this. Okay. What's the difference between multi-level and multiple? There is a big difference, Chandrakant, because if you look at the multi-level, then maybe you can look at this notes here and you see that in multi-level, you are having manager class containing an employee object, which contains a person class object. But in case of multiple inheritance, can you see we are having a lab faculty lab assistant class, in which case you are having both. I mean, you are having the faculty and lab assistant. It's not like faculty is within lab assistant or lab assistant is within faculty. So it's completely different. Okay, in multiple we are having two classes in one single derived class, or two class objects in one derived class, while in multi-level we are having one big object which contains one smaller, which contains even smaller object, like this. So manager is going to have an employee, employee is going to have a person class. Okay, good, very good. So that is the difference between multi-level and a multiple. Generally, it's a little bit difficult to implement it, and that's the reason many languages do not support it. But yeah, Python fortunately supports this, so we have to look at that. And this is how the example can be thought of. Okay. Maybe I'll have to show you here itself because I don't have any space left there. So probably I can show you that example here. Okay, let me show you that example here. I was thinking about to create some space, but it seems like there is none. Or maybe if it is possible, let me just see if it is. We can move it a little bit further. Yeah, we have enough space here. So let us see how the diagram will look like. So we are having two classes here. One is called as faculty, and the other one is lab assistant. So probably I'll just try to make it a little bit smaller so that I can fit both of them here. And there is another one, which is lab assistant. Okay, so we are having those two classes here. So this is the this is the faculty class, and probably the other one is the lab assistant class. Let me just try to make it a little bit smaller. Yep, so that's the faculty class, and that's the lab assistant class. And now we want to go for combination of both of them. So let me just go back here and say this is a faculty lab assistant. That's another class. So this is the derived class. And when I say this is the derived class, you can see that the derived class here is made up of combination of both these base classes. So that's the 1 and that's the 2. I mean, both of them are the base classes for a derived class like faculty lab assistant, and that's the reason you can say it is a kind of multiple inheritance. Understand the diagram, because more or less when you go to company and when you start working on these requirements, then a person will give you a diagram like this. You will have to understand whether it's a single inheritance, multiple inheritance, multi-level inheritance. If you compare it with hierarchical inheritance, you can see that it is exactly opposite of it. So someone said that last time. Yes, absolutely right. If you look at this diagram, the one which I just have drawn here, person having two base classes, you see to one single derived class is having two base classes. It's exactly opposite of hierarchical inheritance. Okay, so this one here is called as a multiple inheritance. Please understand that. I know it's a little bit complicated to understand when you look at it for the first time, but looking at the diagram, hopefully you will be able to see what exactly is going on here. Let me save this first. I'll say that this is the multiple inheritance, and probably we'll add this in our so-called notes. So coming back here, this is an example of multiple inheritance. Let me just go back here. We'll put this now and say this is multiple inheritance.png, and that's where we want to bring it. So this is faculty lab assistant, faculty lab assistant. So that is how it can be implemented, So let me just bring it back. The example here. Don't need this right now. Oh, am I so stupid? Exactly, that's what I was wondering. Like, what the hell I did? Well, what the hell did I do? Exactly, there it is. Okay, we don't need this one. We'll need implementation of it, and that's how it can be implemented. Okay, so this is an example of multiple inheritance. So multiple inheritance is the one where we are having two base classes and one derived class. Faculty lab assistant is derived from faculty and lab assistant. So this is an example of it. Okay. So we have seen one single inheritance, multi-level inheritance, multiple inheritance, and hierarchical inheritance. Now last, it's a combination of any one of those, or maybe multiple one of those. So probably this is a kind of a hybrid. It's a combination of any two or more inheritance types is called as a hybrid. So for example, this is the last example. You can imagine, I'm not going to draw any diagram for that, but you can imagine yourself, because we already have seen all the examples diagrammatically. So you can draw this example on your own. Okay. So probably we are having something like this, say a class person. It doesn't matter whether there is any member here or not. I'll simply add only one for now. So this is the name for your understanding. Maybe I'll have a class called as a player, for example, derived from person. Again, that's a def underscore underscore init. We are having a name and team, for example. Next, probably I'll go back here and say we are having a cricket player, for example. IPL is everywhere, you know, these days. So maybe I can do in this way. So this is a kind of a name, name and team, for example. Maybe I can add one more sport here. Player can play a sport. Which sport? I don't know. So probably, I can say, what the hell? Person dot underscore underscore init will say self and then name. That's it. Then self underscore team, which is equals to team, and then self underscore sport, which sport that person play or the player plays. That is kind of sport information we are taking here. So this is a player, maybe team, and we don't need any sport because I know it's a cricket player. So probably I can say that's the player dot init underscore underscore init, and then we can say self. We are going to pass that name, we are going to pass that team, and the sport, we know that's a cricket because this is the cricket player. No? So that's how we can use that cricket player here. So probably now I can say this is a person player. We are going to go back here and say this is an employee class as usual, like what we have seen earlier. So this is a person class. Along with the person's name, I'm going to need the employee's company. So this is a company information I'm looking for. I'll pass that name to my person's in underscore underscore init method. As usual, this is self and name, and probably self underscore self underscore company is equals to company. As simple as this. And one more, let's say manager, like which I showed you earlier, which is derived from employee. You can say def underscore underscore init, and this is the name, this is the company, and this is the department. So probably I'll pass that employee, the currently those two members, that's the self, that's name and company. I want to pass it to my employee class object, and then we can say self dot department, which is equals to department. That's it. So if you see this example, there is a person class, player class, and cricket class, cricket player class, and then there is an employee class and manager class. So probably if I just go for this quick example, I'm not going to show every single thing. I'll just try to show you the way we can represent it. So we are having different classes. We are having a person class. Wait a sec. We are having a person class. Then I hope the player class. Okay, it's better we can just say the player, then the cricket player, then the employee, and then the manager. You know, so we are having different classes here. See how those classes can be arranged in a particular way and make this as a kind of hybrid inheritance. You see, we are having a kind of hierarchical plus maybe kind of multi-level or you can say a single inheritance. So this is manager. We can add one more if required. Maybe I can say this is the sales manager. So this sales manager is a manager. So this is how we can go for this example, you know. So this is a person class object. This is a player class, maybe object or class, whatever you say, however you want to represent it. This is an employee. This is a manager, and this is a sales manager. So probably if you look at the hierarchy, or if you look at the way the classes are laid out, you see that this is how the relationship can be established between person and a player and a cricket player, like this, and then the employee, manager, and sales manager. So probably this is how we can say that the person and employee, both of them are derived from person, meaning the person is the base class for both of them. So probably you can say it from this way. This is the base class for employee either. So something like this. The cricket player is derived from player, which means player is a base class of this, whatever you can say, filled triangle. And manager and sales manager, both of them are derived from employee. So basically employee becomes the direct base class for manager and indirect base class for sales manager, while sales manager is the indirect indirect derived class of employee. Manager is a direct derived class of employee. Can you see that? If you just pay attention to only this one, this is a single inheritance. If you pay attention to this one, this is a multi-level inheritance. And if you just look at this one, this is a kind of hierarchical inheritance. So it's a combination of multiple ones of them. So this is an example of something called as a hybrid inheritance. And when I say hybrid inheritance, you see that the multiple, or it's a combination of multiple type of inheritances here, not multiple as such, but different type of inheritance. So that's how you can think of it as a kind of example of example of or example of something like a hybrid inheritance. I hope you can understand that. So let me just bring it here and put that in our so-called notes. So this is a kind of hybrid inheritance. That's it. So that's a hybrid inheritance, and that's how it goes, So let me just put that in our so-called notes somewhere here, and then we can say we are done with this. So here we are. It's exclamation mark this one. Sorry. Oh, my bad. I didn't do it. That's the hybrid inheritance. I'm sorry, inheritance. .png. Yeah, here it is. So this is a hybrid inheritance example, and probably if I want to go for hybrid inheritance example, I'll just delete all of them, and we'll get all the classes we have designed so far. There is one more I just need to go for here, and I'll say this is going to be a sales manager. This is sales manager, which is managed, which is a derived class of manager. So probably all of this information, I'm just going to pass it to my manager. So probably this is the department, and on top of it, we are having, let's say, target, sales target, for example, So sales target, or simply the target, which is equals to the target. So this is an example of a hybrid inheritance. So hybrid is a combination of multiple different type of inheritances. So depending again on your requirement, you can go for it. And generally, when you talk about something like real life example, most of the times you will go for something like hybrid inheritance. So this is how the hybrid inheritance can be implemented here. Okay, so probably this is how we can understand how the inheritance is implemented here. Oh yes, my bad. Absolutely, this is going to be a player. Yes, Vikas, absolutely right. It's my bad. It should be a player class, not the person class. I forgot to do it. Absolutely. Did I do it correctly for others? I hope. Yes, absolutely right. Okay, let's look at the quick examples here. Utpal, in hierarchical example, employee is a person and student is a person too. Yes, exactly right. So in hierarchical, when you talk about this, both of them are person. So you can say player is a person, employee is a person. In this case, faculty member, faculty as lab assistant is a faculty, is a lab assistant. In this case, you can say manager is an employee, employee is a person. In a way, you can say manager is also a person. In this case, player is a person. That's how we can get it. Okay. And probably if you look at this diagram, I can say that cricket player, is a person, which means cricket player is also a person. Sales manager is a manager, manager is an employee, and employee is a person, means sales manager is a person, manager is a person, and employee is a person. So this is how we can read it. Okay. Nidhi, your question out of the context, but are we going to learn the Python scripts with browser Excel sheet? Yes, we are. Not right now, but later. Yes, Nidhi, and the answer to your question is yes, we are. Okay, so now hopefully we have seen how to work with, or how to see the different type of inheritances in Python. Precisely, there are 5, starting from single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and finally the hybrid inheritance. Depending on your need, depending on your requirement, you can design your classes using this kind of stuff. Okay. Any questions so far? Have you understood the entire flow here? What happens here? How the things are kind of implemented and stuff like that? Can you please give me confirmation? Yes, at least couple of years. That means all of us, we are on the same page, I hope. So now we can move further. Okay. So let us see how we can go ahead and how we can, just go to the next point and try to call some extra methods, some methods from the base class. So how do we do this? Now, probably if I go back to the another example, I'll just go to the Similar example rather. Now you already know what type of inheritances we already have dealt with. So probably I'm going to simply copy this example as it is. Don't need to write the same example one more time. This is simple single inheritance here. We don't need to say this, it's a single inheritance, because now we can understand it. Okay. Now, important thing here is when I look at this example, there is a person class and there is a player class. It seems like we are having all the information or all the statements in person class, which are again got repeated right inside the player class. But don't you see that? I mean, we are here in object-oriented programming because we want to reuse our code, because we want to achieve the reusability. So how do we do it? I mean, here we can see the three statements are unnecessarily repeated. Can we do something about them? I mean, can we reuse that here? The answer is yes, we can. So how do we do it then? To do it, probably I don't want to go for these statements, because I know these statements are already implemented by my base class. Instead of writing those statements again, you can simply call that method person and what's the name, person dot print person info, and then pass the self. So possibly this is the way, you can say, way to call the base class method. So base class method, that's how we can go for it. So probably someone was asking that question, like, how do you do that? How do you call the base class method? This is the way you can call the base class method. Okay, Utpal, look at this one more time. Earlier, the scenario was I was having exactly same statements in my base class print person method. At the same time, my derived classes print player info method. So both of them are kind of having the same code, and we wanted to reuse the code. That's the reason why we are going for object-oriented programming. So if you want to reuse the code, why are you repeating the code? I mean, isn't there any way you can reuse it? I said, yes, this is possible. And to make it possible, we are going to delete that code, and instead we are going to call this method here. So this method is already having the information of a person. So simply call that method here by saying person, which is the base class name, underscore print info, print person info. That's a method I want to call, and pass the self here, self as it is here. So now if I go back and try to run this code, there is no difference. I mean, last time also I was getting the similar output. Here is also I'm getting the similar output. The only difference here is I try to reuse my code, which is already implemented in my base class. So this is the right implementation here. So probably Utpal, you must have got it now. So this is the way we are achieving the reuse or reusability of that code from base class to derived class. Someone was asking that question last time, how we can call the method from base class to from a derived class of base class method. This is the way you can do it. Okay. So probably whenever you are calling any method, just make sure that you are using the base class name, whatever base class name you are using there, dot name of the method you want to call, and don't forget to pass self. That's very important here. So you'll have to pass the self as it is. That's how it goes. Okay, so now we know that this is the way we are kind of calling the calling the base class method. I hope now it becomes very easy for you to reuse your code. Yeah, Adesh, I want to reuse the method, but want to restrict the sum of the print functions. Then is it possible? Want to restrict some of the print functions? No, you can't. Once you try to call this method will get completely called. It's not like half of the method can be called, half of the method will not be able to call, not like that. So whenever you are thinking about making a call to your base class method, the method by default will get called. Okay, so that's how it goes. Okay, so now you know like how the method can be called from derived class. Don't you see there is a small problem here? So probably whenever I'm thinking about creating an object of person, now please try to visualize it. When I'm trying to call that method, I think it's better we can save this somewhere. Not required, it's already been saved. Now we need to save this one rather. Just give me a sec, let me save this, and then let me go back to the example I talked about earlier. So it will be easy for me to again talk about it and just show you what exactly the point I'm making here. Maybe this is SCPD, that's September 21 _ 4. 4 is already there, fine. Okay, now look at this example here and try to understand this now. Okay, just give me a sec. Let me open the previous example here. I just want you to visualize this, that's it. So probably look at this example. So probably I'll just open this and we'll try to visualize this example one more time, So when you talk about this example, you are having a person class, you are having a something like a player class, and this is how we can visualize it. That's a player class object which is having a person within it. Okay, so think about this from this perspective. So this is a player class. Just give me a sec. Let me just arrange it in a little bit different fashion so we can reuse it from or maybe reuse it for this particular use. Now let me just go back and say this is the player class. Okay, now please pay attention to the way I'm showing some code here. I'm trying to show you some kind of reusability concept again. When you talk about this player class, you see that the player class is having two methods. One is the print player info, another one is the print person info. You know that print person info is given by person and print player info is given by player. Okay, think about this requirement and then we'll show you some maybe some different concept here. When I call, understand this, when I call player dot print person info, in that case, let us see what happens. If I call print player info, there is no problem. You can see that when I call the print player info is available in the player class. So the method will get called from here. But when I call the print person info, see what happens. Player will first search for print person info within its own class. Do I have a print person info inside the player class? No, I don't think so because it's not been mentioned here. So what does it do? It goes to its base class. So it will first search that class. It will first search that method within the same class, and if it finds it there, it tries to call that method from the same class. But if it doesn't find the method, then it will jump to the base class method and it will try to find it whether the print person info is there. I mean, fortunately, the method we are trying to call print person info, it's there with the person class, and that's the reason the method will get called from print person info. Watch what happens. If I call a method player one dot a test method, I know test method does not exist, but still, let me just give it a try and see what happens. First, the test method will be searched here inside the player class. Do we have test method? No. So it goes back to the person. It will be a person class now, which will be searched for test method. Is test method there inside person class? No. So after that, there is nothing, rather there is no base class of person right now. So think about it. The method does not exist in the derived class as well as in the base class, means the method really doesn't exist, and that's the reason your application will crash and will say that, hey, player object does not have an attribute of test method. What I'm trying to show you here is the way the method's existence will be checked. Whether the method exists or not, that will be checked based on the fact that either the same class is having it or it's a base class is having it. If the same class is having it, the method will be called from here. If its base class is having it, the method will be called from the base class. So that is how the method will be checked against existence against the same class first and then the base class later. Think about another example, maybe a multi-level example somewhere here. What happened? I mean, we lost it. I don't know. Maybe if I go for the other one, here it is. So let's imagine that we are calling a method on a manager. So if the manager class is having that method, it will be called from here. If it doesn't have that method, then the employee is the one where we are going to search that method for. So if the method is available in the employee, the method will be get called. If the method is not available in the employee, then we'll check that method's existence in the person. And if person is not having that method, then we'll say, hey, the method does not exist. You getting the point here? So the point here is, whenever you are calling a method, always the existence will be checked within the same class first, or the priority will be given to the same class first. And if the method exists in the same class, the method will get called from there. If the method does not exist there, the method will be searched in its base class. If it is not there, then it will be searched in its base class and it will go till the end. And then if the method doesn't exist at all, you will get this error saying, hey, person or whatever class does not have any attribute named that method name you are trying to call there. Okay, so that is how the method's existence will be checked. Fine. Now what? Now, when you talk about this method existence, probably you see the method existence will be checked within the same class. So what the point I'm making here? See this. Right now, if I want to print the person info, I need to remember that the method name should be the print in person info. So if I want to print the person info, I'll have to remember that that's a print person info. If I want to print the player info, then it's not the person info. I need to call the player info method. So being a developer, I need to remember the method name in order to print the right information. If I call print person info on top of a player class object, will not be able to see the team data. So let's try this. If I call the same method print person info on player, you see I'm getting the player's name, player's address, player's age, but nowhere I'm getting the player's team. So I need to remember that the method which I need to call on player is not the print person info, it's rather the print player info, which means this is going to give me the team information here. So I need to remember this every single time. What I'm trying to show you here is another facility, another kind of concept here, which will make your life so easy. Let me just make one more page 7, and let me try to fix this problem. To fix this problem, what I'm trying to show you here is, instead of keeping different methods like print person info, print player info, why don't you just go for a method like a print info here and a print info here? Okay, so we are having a print info here, we are having a print info here. Of course, there is no print info, so a print person info, there is a print info only. So now if I look at the new definition, the class will have, maybe I'll just go back here and we'll try to show that very quickly. The class will have something like a name. This is a player class we are talking about. So maybe the player class is going to have a name like this. Maybe I'll just try to use it as a name. Let's say person 1, for example. Maybe player class is having an address. Okay, leave that name, other things, just name is more than sufficient. And a method is print info. This is the person class object, On top of it, we are having a employee class object as well. So probably this is the player class. And on top of that, we are having an employee class. Watch what happens here. So on employee class, I think we are having, or player class, sorry, not employee, that's a player class. We are having a player, let's say Mumbai. It's a team, the player's team is equals to Mumbai. So what is going to happen here? See, we are having a attribute called as a team, and then we are having the same named method print info. So probably when you think about this scenario here, you can say that now we are having one more wrapper on top of it. This is my player class. If it is a player class, you see the player class is having an attribute team, and the player class is having a method print info. Again, this one is a person class, the one which you see here, and the one which is on top of it is called as the player class, So now if I have an object of player class, see what happens here. There is no print person info anymore. There is no print player info anymore. Now I'll see what exactly is going to happen. So when I create an object of these two, like person and player, whenever you are having a person class, there is no doubt print info will be called from person object and everything will go smoothly. Now let us see what happens when I call the print player.printinfo. So when you say player.printinfo, first the method will be checked here, and you can see that the player class is already having a method named printinfo. So printinfo in this scenario will be called from player class and not from the person class. One more time. When you call person.printinfo, there is no second thought because that's a class object we are creating. This is the method that will be get called. When you create an object of player class, there should be a little bit confusion because I see the method name here and the method name here, where the method will get called from. So probably in this context, if I'm creating a player class object, the method will always get called from player class itself. Why? The reason is because the method existence will be checked in the same class first, and then it will go to the derived class, then it will go to the base class. So because my derived class player is already having that method with the name print info, the method will be called from here. And if you don't believe me, let me just go back here and say print. Let me add a dash here and say this is going to be 30, for example, and say this is going to be print. What is that method? This is a player class method. So player class print info. So let's see what happens here. Let me not call this method right now. I'll just go back here and say this is going to be a person class info. So probably person class print info. I'll just show you this, how this implementation is getting called. So if I say run, probably you can see that when I call that method on person class, you see the person class method gets called. And when I call that method on player one, you see, that's the player one dot print info. It calls that method from the player class. So it is guaranteed that whenever you are calling this method on player class object, the method will get called from player class instead of the person class. The concept which I just talked here, let me summarize it. Whenever you are having two methods with the same name, one is in the base class, one is in the derived class, and the methods are having exact same name, then when you call a method on the derived class object, it will always get called from derived class. This concept in object-oriented terminology is called as method overriding. Method overriding means a derived class is implementing its own definition of that method. If a player class doesn't implement this method, what is going to happen? If the player class doesn't implement this method, that means the method would not exist here. If the method would not exist here, and if I call that method, if the method is not there, it will go to the base class and it will try to call that method from here. But because the method exists, that means if the player class has implemented its own definition of it, its own implementation of it, then the method will be called from the player class and not from the person class. So point to be noted here is like when you are in a situation, there is a base class, there is a derived class, both of them are sharing the same method name, then this concept or this implementation is called as method overriding. Method overriding is the way we can implement our own implementation, or we can add our own definition for that method which is already given by person. So person has given print info. Now a player is giving its own information here. So if player doesn't implement it, by default it will get called from person. But if player gives a definition of new definition of that print info, then it's getting called from the player class, not from the person class. This is called as method overriding. The one which I just mentioned here, this is true across all programming languages with little bit syntax change. Concept remains same. Okay, yes, Rajendra, I think you got the point. Vipin, what are you saying? If like a Java has a super class and all the classes are called as object, is there anything in the Python? Yes, wait a minute, I'll talk about it. Let's finish all of these things and then I'll reveal a secret. Okay, so Vipin, just hold your question for a minute. You will get an answer. Nidhi, what if the player print info accesses the person print info? That's what we already have done here. Doesn't matter which method is getting called first, player class. So what exactly you have done here, it depends on you. But whenever you are talking about the person class, the player print info of player class, then always this will be the case. You may call this method from here to here. It's up to you. What you want to do here, it's really up to you. I mean, you call that method here by using the person of print info and do whatever you want to do. But this method is guaranteed to get called. It will never go to the person class directly. So Nidhi, I think you got the point here. Hopefully the method always will get called from the player class and not from the person class directly. It's your choice to call it, to call the person class method from the player class or not. Okay. Ketan, is there any facility for calling base class method implicitly? That's what we have done here. So Ketan, not implicitly in a sense, without having this line, No, this will never, but here we are calling it explicitly. Okay, and actually speaking, no language will provide this kind of implicit call functionality, just because it's kind of risky. I mean, it's not needed. The whole purpose of having one method implementation here for print info is to modify the method or modify the implementation given by the person class, you know. So no language, hopefully you can see any other languages there, and no language will give you this functionality to call the superclass method or maybe the base class method implicitly. You have to call it explicitly if you really want to. Okay. Okay, so I hope you are getting this point, that whenever you are in a situation that you are having a base class, derived class, and both of them are sharing the same method name, this concept is called as method overriding. And technically speaking, method overriding is the way we are kind of giving a new definition of that method, which is given by your base class. Okay, so that's the way you can do it. Now, sometimes maybe I'll just go back here and say, maybe I'll create a separate example here, and hopefully you will understand this quickly. We'll see. When I say there is a class called as, maybe I'll say a class called as a bird. Just a simple example here, you know. So this is the bird class, which is having, let's say, name right here. What's the name of that bird, or what's the hell? What's the name of that bird, and other information you want to keep there, for example. That's it. And let's say there is a class called as a crow. Now I know crow is a type of bird, you know. So probably I'll just go back here and say crow is derived from bird. So probably I can say def, and I can say init. I don't want to take any name from my initializer, because I know I can create, or I can call that bird and say underscore, I'm sorry, underscore init underscore, and then self. I know this is the crow. So maybe I'll say this is the crow class, or crow name for that particular bird. I'm going to go for another one. Maybe I'll say, let's say that's a duck, for example. Duck is also part of a bird family. So for example, I'll go back here and say this is a duck, and say underscore init. And then I'll say this is the duck. Okay, I'm sorry, my bad. This is the self. We don't need any name here. We are going to call that bird dot underscore init. This is the self, and I'll say that this is the duck. So we are having three classes here: bird, crow, and duck. Looking at this example, can someone tell me what is the type of inheritance we are using here quickly? Exactly, it's hierarchy, right? It's hierarchical inheritance. So we are having one base class and multiple derived classes. This is an example of not multi-level. It's a kind of, yes, hierarchical inheritance. Absolutely right. So when you talk about this, in my base class, or in my bird class, I'm going to create, let's say, make sound. You know, that's what I'm going to say. So printf, I'll say print, maybe bird is making sound. Bird is making sound. That's it. So here I'm going to say that make a sound. So maybe there is a bird, and bird is going to make a sound, for example. Now I know that the sound of crow is different, the duck is different, and the other birds are making their own different sound, own different way to just call their colleagues, or call their other birds there. So probably what I'm going to say here is, like, if a duck has a special way of making a sound, so probably I can override this method here and say, hey, duck has a special way of making a sound. So maybe if any method is getting called on the duck class, see what happens here. Maybe I can say print and say duck says quack quack, for example. So duck has a special way to make a sound, something like a quack quack. So what is going to happen now? Check this out. We are having a bird b1, which is a class of bird, which is an object of a bird class. I don't know what's the name here. I'll just make it as a bird, for example. Then we are having a crow. Maybe I'll say c1 is equals to crow. Sorry, what the hell, crow. And we don't need any, we don't need to pass anything there. I need one more, let's say d1, that's the duck. We don't need to pass anything here as well. See what happens. I'll say b1 dot make sound. So probably you can understand the make sound will be called from bird. I want to say c1 dot make sound, which means it's kind of c1, that's crow, is making a sound, and there is a d1, that's d1 dot make sound. So probably when you say b1 dot make sound, the b1 dot make sound will call from the bird class, because we are creating an object of bird. So that means it's going to get called from the will get called from the bird class itself. When we are having a crow class, you see the crow class does not have an implementation of make sound. So first the method will be checked inside the crow class. Crow class doesn't have any method with the name make sound. So it will go to its parent class, that's or its base class, that's a bird class, and the method will get called from here. But when you look at the duck class, and if you say that make sound, the duck class already has implemented its own method make sound. So the method will get called from the duck class and not from the bird class. So this example, I'm trying to show you that there are two classes which are derived from one base class. One is overriding it and another one is not overriding it, which means this class duck has overridden the method, or duck class says my way to make sound is different. So I'm going to say quack quack here. Crow says I don't have any special way. I'll say crow or cow cow, for example. I don't want to make that sound here. I use the default sound which is given by bird. So when I say run, you see any bird can make a sound. The bird is making a sound which is again called from the crow, and probably here I'll say duck is saying quack quack. Precisely instead of saying bird, I'll make use of self underscore name. So precisely we can say who is making what type of sound. So the bird is making a sound, the crow is making a sound, and the duck says quack quack. You see, the duck implementation is a little bit different than the crows and the birds implementation. If tomorrow crow says, no, I want to make my own sound, not a big deal. I'm just going to go back here and say this is going to be the crow's implementation. So crow says, what should I say? Crow says cow cow, whatever. Crow says cow cow or KK, for example. So probably you can say now crow has its own implementation. Last time crow was making a simple sound or normal sound, but crow now has saying cow cow. Let's say KK, for example. So duck has its own way to make sound. Crow has its own way to make sound. What's the point of implementing this method here? I mean, you know that this method will never get called when I create an object of crow and duck. So probably what is the way of having that method here in the make sound or in that bird class? And that's the reason most of the times when you don't need that method implementation here, because I know in my application, I never will create an object of bird class. I just created the bird class so that, I can go for creating the crow class and duck class, and I can share some information there. So I can share that name information in bird class, in crow class and duck class, and I'll just make a kind of understanding that crow class and duck class can be can make their own sounds. So basically, make sound in bird will do nothing, and that's the reason I'm going to make it as a kind of an empty method. I still remember someone was asking that question way back when I showed you a pass keyword when we created that definition or when we created that function for the first time. And someone was asking that question like, why on the earth do you need to make a method as an empty method? What's the point of creating an empty method? So I mentioned that time. Later on, when we go to object-oriented programming, you will see a kind of an example where you have to make a method as a kind of empty and let the other derived class methods to override the meaning of it. This is an example I talked about earlier. I don't remember whether you can, I don't know whether you can recall this fact or not, but I gave the forward references previously. This was one of the references there. So whenever you think about a requirement that the bird is any general bird is not going to make any sound, for example, there is a crow having its own habit, duck is having its own habit. This is the way to make a method which is non-functional, or you can say it doesn't do anything. But when you say crow has its own way of implementation, duck has its own way of implementation. If you are coming from C++ part of the world, there you make this as a pure virtual function. And if you are coming from Java part of the world, you'll make it as an abstract class or abstract method. Here in Python, there is nothing called as abstract, but here you're trying to say this method has no meaning in bird class. The only thing here is like bird is just kind of considered as a unit that can share some information with crow and duck. This is where we need to keep that method as empty. Anyway, so probably now you can see how to use that method overriding feature and how the crow class and duck class can implement their own way to make the sound. So that's an example of method overriding. So guys, remember, when you are in Python and if you want to override a method, all you have to do here is just use the same name of that method which your base class already has written inside it. So if already the base class is saying make sound, just use the same class, same method here, make sound, and the method will get overridden automatically. I hope you can understand. You cannot have multiple methods with the same name in Python in the same class. I'm not talking about the same class here. This class is different, this class is different, this class is different, this class is different. So probably I'm talking about the hierarchy here or the inheritance here, where the base class and derived class, two different classes sharing the same name. This is called as something like a method overriding. Okay, when you are having multiple classes or maybe the child or parent classes having the same name in both the classes, it's called as a method overriding. Method overriding will give you a functionality that the method will always get called from the derived class first, and if it is not there, it will be kind of called from the base class. Concept is very simple. If you can understand this diagram, concept is very simple, but it's the way you can implement it in Python. This is what they say, the duck typing in Python. Exactly, duck typing in Python in the sense the duck is of type bird or crow is a type of bird. That's what you are saying. Absolutely brilliant. Okay, so probably we just have got introduction to this this part, method overriding. In tomorrow's case, you will see the actual use of this method overriding. I mean, where can you use it? Or what's the general use case of having a method overriding in the real world? So tomorrow you will see that. We are going to talk about something called as operator overloading, which is implemented in Python based on the same fact, method overriding. So tomorrow's case, we're going to talk about operator overloading. There are many operators we are going to overload, and we'll see how to deal with them. Okay. Next, if time permits, tomorrow we'll go for the exception handling, and that is the end of object-oriented programming. And then we'll start with the module, packages, and stuff like that. Okay. So probably tomorrow or maximum day after tomorrow will be our last session of Python. Don't worry, last session of Python is last session of Python as a language. After that, we'll play with different packages. Remember, I promised at least 5 to 6 packages. So we are going to start talking about the packages one by one. Okay, so till maybe end of the day tomorrow or maximum day after tomorrow, we'll discuss all the Python, and then we'll start talking about all the packages. I know officially I think today or tomorrow was our last day, but that's not going to be the case. We are going to extend it by at least 1 week. So it will be there till at least the next Saturday, not this one, till next Saturday. Okay, so probably you will see the different packages out there, how they can be used in the real world, what are the use cases, what type of different functionalities they will provide to you, and so on and so forth. Okay, Utpal, ideally which way Python programming it to follow, OOP or POP? It depends on the context you are writing the program in. If you're writing a huge program, OOP is preferred. If you're writing small program, POP is preferred. It depends on the context, it depends on the requirement you are following. Okay, Python provides both the ways, but you have to decide which one you want to go for, either this or that. It's up to you. But generally, if you're developing a large application, go for OOP. If it is application is very small, go for POP. Okay, I think that is it for today. I think it's better we can continue for the next part. Okay, what is that, Vipin? Same question, sir. You asked me the post at the end of the module. What was the question? I forgot to do that. Pranit, your question, just one request, all of us hint to add the directory like the data member in the class. Or will you give a hint to add a directory like the data member in the class? Not getting your point, Pranit. Can you just make a kind of, can you just elaborate what you're saying? Add a directly like a data member in the class means I'm not getting you. Dictionary, sorry. Add a dictionary like a data member in the class. Okay, exactly. I'll talk about this later once we are done with this. Or maybe just remind me tomorrow. I'll talk about what happens internally, how the data gets implemented internally. It's actually, I mentioned it earlier, but I'll just go in a little bit in the depth. Okay. Anyways, I think this is it for today, guys. So we'll continue tomorrow, and probably tomorrow we'll see some other methods as well. Virtual function support in Python. Ketan, did you miss something? Virtual functions are required to override the method in C++. This is how the method will be overriding in Python. So there is no keyword called as virtual. If you're coming from C++ world, then there we have to create a virtual method in base class, and then that same name will be used in the derived class to override it. Here we don't need it. Here we don't need virtual at all. Okay, so that's how you can go for virtual implementation in Python. It's called as method overriding in Python, by the way. Okay. Anyways, so let's call it a day, guys. We'll see you. We'll start again the next topic tomorrow morning exactly at 8 o'clock. Till then, have a very great day. I'll see you tomorrow. Bye bye. I'm going to share these notes with you by after we are done with this. Okay, so you will get the new versions of this code as well. Okay.